If you are studying for the KCNA exam, Kubernetes is one of those words you are going to hear a lot, and at first it can sound intimidating. Pods, nodes, clusters, control planes, services, deployments. Yeah, it can feel like someone spilled alphabet soup into a data center. But don't worry, Kubernetes sounds scarier than it is. In simple terms, Kubernetes is a system that helps run, manage, scale, and recover containerized applications. And in this quick bite, we're going to break down what Kubernetes is, why it exists, how it works at a high level, and what you need to remember for the KCNA exam. Welcome to QuickBytes Education. Today's quick bite is all about Kubernetes, explained simply, quickly, and clearly. Let's get started. Kubernetes, often shortened to K8s, is an open-source container orchestration platform. Now, let's slow that down. A container packages an application with the things it needs to run, like libraries, dependencies, and configuration. That makes the application easier to move between environments, such as a developer laptop, a test server, or the cloud. But here is the problem. Running one container is not too bad. Running hundreds or thousands of containers across multiple servers? That gets messy fast. You need to decide where containers should run, restart them if they fail, scale them when traffic increases, connect them to each other, update them without breaking everything, and keep track of what is happening. That is where Kubernetes comes in. Kubernetes is the tool that helps manage all of that. It does not create your application. It does not magically fix bad code. I wish it did. We would all have much shorter troubleshooting calls. But Kubernetes helps operate containerized applications in a reliable and automated way. Kubernetes exists because modern applications are often built from many smaller services instead of one giant application. For example, an online store might have one service for user accounts, one for payments, one for inventory, one for shipping, and one for recommendations. Each service might run in its own container. Kubernetes helps keep those containers running, connected, and scalable. For the KCNA exam, remember this phrase: Kubernetes automates deployment, scaling, and management of containerized applications. That is the big idea. Think of Kubernetes like a very organized operations manager in a busy restaurant. The containers are the workers doing the jobs. The application is the restaurant service. The servers are the kitchen stations. Kubernetes is the manager watching everything. If one worker stops working, Kubernetes helps replace them. If the restaurant gets busier, Kubernetes can help add more workers. If a station is full, Kubernetes can place work somewhere else. If the menu changes, Kubernetes can help roll out the update in a controlled way. That is the basic idea. Kubernetes helps keep the application running the way you asked it to run. One of the most important Kubernetes ideas is desired state. This is where people usually overcomplicate it. In Kubernetes, you describe what you want, and Kubernetes works to make the actual system match that desired state. For example, you might say, I want 3 copies of this web application running. Kubernetes checks the current state. If only 2 copies are running, it starts another one. If one crashes, Kubernetes replaces it. That is called self-healing. You are not manually babysitting every container. Kubernetes continuously works to keep the system close to the state you declared. For the exam, remember, desired state means what you want. Current state means what is actually happening. Kubernetes controllers work to move the current state toward the desired state. A Kubernetes environment is called a cluster. A cluster is made of 2 major parts, the control plane and worker nodes. The control plane is the brain of the cluster. It makes decisions, stores cluster information, watches for changes, and coordinates what should happen. Worker nodes are the machines that actually run application workloads. A node can be a physical server or a virtual machine. For the KCNA exam, understand this. Control plane equals decision-making and coordination. Worker nodes equal running the workloads. Let's talk about the main components you should recognize. The API server is the front door to the Kubernetes control plane. Tools like kubectl communicate with the API server. etcd is the key value database that stores cluster state. The scheduler decides which node should run a pod. The controller manager runs controllers that watch the cluster and make changes when needed. On the worker node, the kubelet is the agent that communicates with the control plane and makes sure containers are running as expected. The container runtime actually runs the containers. Kubeproxy helps with network communication for services. Do you need to be a master administrator for the KCNA? No, but you should know what these components do at a high level. Now let's cover the Kubernetes objects you absolutely need to know. A pod is the smallest deployable unit in Kubernetes. A pod usually runs one container, although it can run more than one if those containers need to be tightly connected. A deployment manages the rollout and desired number of pod replicas. A replica set helps make sure the correct number of pod copies are running. A service provides stable networking access to pods, even when pods are replaced. A namespace is used to organize and separate resources inside a cluster. A config map stores non-sensitive configuration data. A secret stores sensitive information, such as passwords, tokens, or keys. A volume provides storage to containers. A persistent volume and persistent volume claim help support storage that can survive beyond the life of a single pod. These terms show up a lot in Kubernetes learning and KCNA-style questions. Kubernetes helps with several major tasks. It schedules workloads across nodes. It restarts failed workloads. It scales applications up or down. It provides service discovery and load balancing. It supports rolling updates and rollbacks. It manages configuration and secrets. It helps connect workloads to storage. It gives teams a consistent way to run applications across environments. That is why Kubernetes is such a big part of cloud-native computing. For the exam, also know what Kubernetes is not. Kubernetes is not a container by itself. Kubernetes is not Docker. Kubernetes is not a cloud provider. Kubernetes is not a traditional virtual machine manager. And Kubernetes is not automatically serverless, although serverless platforms can be built on top of Kubernetes. Kubernetes is a container orchestration platform. That is the clean exam answer. Here are a few common mistakes to avoid. Mistake number 1. Confusing a pod with a container. A container runs inside a pod. Kubernetes manages pods, not individual containers directly. Mistake number 2. Thinking the control plane runs your application. The control plane manages the cluster. Worker nodes run the application workloads. Mistake number 3. Forgetting that services provide stable access to pods. Pods can be created and destroyed, so services help provide a consistent network endpoint. Mistake number 4. Thinking Kubernetes only matters in the cloud. Kubernetes can run in public cloud, private cloud, on-premises environments, and local learning environments. For the KCNA exam, focus on the big picture. Kubernetes manages containerized workloads. A cluster includes a control plane and worker nodes. Pods are the smallest deployable units. Deployments manage application updates and replicas. Services provide stable network access. Namespaces organize resources. Config maps and secrets provide configuration. Volumes provide storage. The Kubernetes model is based on desired state, automation, and self-healing. If you understand those ideas, you are building a strong foundation. So, what is Kubernetes? Kubernetes is an open-source container orchestration platform used to deploy, manage, scale, and recover containerized applications. It helps teams run applications reliably across clusters of machines. The control plane manages the cluster. Worker nodes run the workloads. Pods run containers. Deployments manage pods. Services expose applications. And Kubernetes constantly works to keep the actual state of the system close to the desired state you defined. In one sentence, Kubernetes is the platform that helps keep containerized applications running, connected, scalable, and resilient. Subscribe and keep building your knowledge with QuickBytes Education, one QuickByte at a time.